Welcome back to All This Math. This is Professor Parker. Let me make sure my microphone is okay. I'm cool. Yeah. So, like I said, welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the All This Math YouTube channel. Please make sure you go ahead and like the video. Also, share this video with somebody. All right. We're dealing with combinatorics, permutations, and combinations. Even though I'm not going to get into those formulas in this video, I'm gonna do the problem in a different way using the what we call the either called the fundamental counting principle or the multiplication principle. One of those two. All right. Share this video with somebody, and also if you have any questions or comments, drop your questions or comments in the comment section down below. All right. So first, before we get started, though, I want you to check out my hoodie. Check out these names on my hoodie. Some of them you may be familiar with. Some of them you may not be familiar with. You may not be familiar with none of them, but I highly recommend you educate yourself on these names. These brothers who are named. First, we have Gabriel Prosser. Gabriel Prosser organized a slave rebellion in the year 1800 in Richmond, Virginia. All right. Next, so all of these brothers were involved in different slave rebellions, right, in different parts of the country, different parts of the Western Hemisphere. Then we have Denmark Vesey. Denmark Vesey organized a slave rebellion in the year 1822 in Charleston, South Carolina. All right. Then we have Nat Turner. Nat Turner is probably the most famous, you know what I mean, of these names. He organized a slave rebellion in the year 1831 in Southampton County, Virginia. All right. And then we got Charles. Charles is the first name of a brother named Charles DeLon. Charles DeLon was down in the New Orleans area near Orleans Parish. He was instrumental in a slave rebellion down there on what they call the German Coast Rebellion, which took place in the year 1811. All right. And last but not least, we got Colonel Johnson. Colonel Johnson was in Jamaica. He wasn't in the United States proper, but he was in the Caribbean in Jamaica. He was involved in what some people know as the Christmas Day Rebellion. Some people know it as the Baptist Rebellion. It took place on Christmas Day in the year 1832. So you may be familiar, you may not be familiar, but if you are familiar, get more familiar. If you're not familiar at all, there are books that have been written about these slave rebellions, and there's a lot of information on online resources and in other books and in articles. All right. It's important for us to know as a people to know about this history of slave rebellions. We weren't just laying down, taking it. That's, that's historical revisionism. That's what that is. But definitely go do your research on different slave rebellions. And this is not the entire list. This list is not exhaustive. There were many, many others and many people involved in those others. All right. So what about the math though? Right? We're doing some HSPT math, high school placement test for 8th grade students that are, attending Catholic schools and or maybe other parochial schools. This is an example of one of the questions that you may see on the HSPT math exam, which is a measurement of their mathematical proficiency by the end of 8th grade. So, what does the question say? How many possible outfit combinations can be made from 6 shirts, 3 pairs of slacks, and 5 ties? All right. So, the quick and dirty way to do a problem like this is you take the numbers and you just multiply them by each other. 6 times 3 is 18. 18 times 5 is 90. Make sure you know your multiplication facts so you can figure out that 18 times 5 is 90. All right. So that means there are 90 total combinations. All right. But let me take a couple minutes and talk about why there are 90 total combinations. So let's think about this, right? Let's say we got 6 shirts. So we got shirt 1, shirt 2, shirt 3, shirt 4, shirt 5, and shirt 6, right? Each of those shirts can pair with each of these 3 slacks. So that means we got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then with the 5th shirt, 1, 2, 3. And last but not least, the 6th shirt, we got 1, 2, 3. So when you count them up, now you got 18, right? Because that's 3, 3, 3, 3, 3, and 3. 6 threes, that's 18, right? 3 times 6 is 18. 6 times 3 is 18, right? Now, but what if each of these could get paired with 5 different ties, right? So each of these 18 possibilities could be paired with 5 different ties. So then you got 5 ties here, 5 ties here, 5 ties here. So notice the pattern. This is 18, right? No, actually, no, this ain't 18. Well, this is, so the one pair of slacks, no, the one shirt, the first shirt, right, can match up with 3 slacks. All right. So that's going to be, so the one shirt is going to match up with the 3 slacks. Then you got, and then, but it's 5 ties though, right? So you could either put one of the top, you got 5 different combinations, right? So 5 different options, 5 different ties, right? You could put the 5, like this one shirt with this pair, with this pair of dress slacks, and you got 5 different ties you could do. You got the one shirt, the first shirt with this other pair of dress slacks, 5 different ties you could do with that. And then the same shirt, the other pair of dress slacks, 5 different ties with that. So that's 15 combinations, right? That's 15 combinations. That's 15 combinations, right? We could duplicate that for every shirt. So the second shirt, each of the dress slacks, you could match up 5 different ties with each of the shirts, shirt number 2 and dress slacks. So each of these is going to be 15. All right, let me break it down again on where I'm getting the 15 from. All right, I want you to know where I'm getting the 15 from, because look, shirt number 2, pants 1, pants 2, pants 3, right? So each of these pants, right? This shirt, each of these pants, I got 5 different options for ties. 5 different options for ties. So I got 5, 5, and 5. Altogether, how many is that? 15. 15 options, right? Now, if it's 6 of these, I got 15, 15, 15, 15, 15, and 15. What is 15 times 6? 15 times 6 is 90. This is a trick I showed my nephew Maceo the other day. When you multiply 2-digit numbers by 1-digit numbers, you can decompose the 2-digit number into a 10 or a number that ends in 0. In this case, it's going to be 10. 10 and a 5, right? We got 10 plus 5, and then 10 times 6 is going to be 60. 5 times 6 is going to be 30. 60 plus 30 is going to equal 90. So either way, we get 90. Even though this may not look the way this looks, 6 times 3 times 5, right? It might not look like that, but it ends up being 90 either way. All right, with your tree diagram. That's what that's called. Earlier today, I couldn't remember what this was called. A tree diagram, right? And if we wrote it out, right? If we wrote it out explicitly, we'd be able to count 90 different outfits. We'd be able to count 90 different outfits. But instead, you see we have 15 associated with shirt number 1. You got 15 associated with shirt number 2. And then the same would apply with shirt number 3, 4, 5, and 6. So that's why this makes sense. So that's why it ends up being 90. But the quick and dirty way is you just multiply the different amounts, the amounts of the different items, the number of shirts, the number of dress slacks, and the number of ties. Just multiply them out. So something to think about if you're an adult watching this, and you going on vacation or something, and you trying to map out, playing your outfits and all that. Just something to think about. This is how you get 90. All right, and this is problem solving. All right, so if somebody's wondering, well, why I got to know this? How's it gonna help me in life? Because when you have strong math skills, no matter what the topic in math is, you're training your brain for problem solving, and you need to know how to solve problems, right? To be a responsible human being, you need to know how to solve problems, because we inevitably will have problems, and life gets real uncomfortable if we don't know how to solve our problems. We need to know how to solve problems. All right. So make sure you subscribe to the All This Math YouTube channel. Make sure you share this video with somebody. Share the channel with somebody. All right. Also, go ahead and like the video. And also, if you still have questions about this concept, combinatorics, combinations, permutations, the multiplication principle, put your question in the comments, and I may make a follow-up video to give you more clarity. All right. See y'all on the next video.